Hello everyone, welcome to today's video on adding and subtracting polynomials. And the first step in doing this is removing the brackets. So in our first example, we have 5x plus 2, and then we're adding the polynomial 2x minus 1. So that positive sign needs to be applied to all the terms inside the brackets that's to the right of it. So that positive sign needs to be applied to the 2x, and it also needs to be applied to the negative 1. When you multiply anything by a positive number, it doesn't change the sign. So positive 1 times 2x just gives us 2x, and positive 1 times negative 1 just gives us negative 1. So that's how we arrive at our answer down here. And in our second example, we have 3y plus 5x, and then we're subtracting the polynomial 3y minus x. So that negative sign needs to be applied to the positive 3y. So negative times positive gives us a negative number. So that's how we end up with this. And then negative times another negative gives us a positive. So that's how we end up with the positive x here once we've expanded. And then the second step in adding and subtracting polynomials is to collect like terms. So like terms are terms with the same variables raised to the same powers. So x and 3x and 4x would all be like terms, but x and 3x squared and 4x cubed would not be like terms because they are raised to different powers. So sticking with our examples from earlier, we have 5x plus 2 plus 2x minus 1. So our 5x and our 2x would be like terms because they both have x raised to the power of 1. And our constants would be like terms because they don't have any variables. And for our second example, we have 3y plus 5x minus 3y plus x. So our 3y and our negative 3y would be like terms because they both have y raised to the power of 1. And then our 5x and our x would be like terms because they both have an x raised to the power of 1. And then when we collect the like terms and simplify, our 3y and our negative 3y cancel out, and 5x plus x just gives us 6x, and that's how we arrive at our answer here. And now I'm just going to go over some examples with you guys to really hone in on this. So here we have 6x minus 3 plus x plus 5. So when we apply a positive sign to all our terms inside the bracket, it doesn't change the sign. So we end up with 6x minus 3 plus x plus 5. And our like terms would be the x's, and then our other like terms would be the constants. So 6x plus x would give us 7x, and 5 minus 3 would give us 2. So that's 7x plus 2 as our answer. For question 2, we have a negative sign being applied to both of our terms inside the brackets, so to our negative a and also to our negative 6. And so we can rewrite this as 8a plus 2. That stays the same. And then negative times negative gives us a positive a, and a negative times a negative would give us a positive 6. And now when we simplify, 8a plus 1a would give us 9a. And 6 plus 2 gives us 8. So that would be our answer. For question 3, we rewrite the first part in our second line. And then a positive sign does not affect our signs for our terms within the brackets. So we can just rewrite them as is. And now we're going to gather like terms. So our x squares belong together, our x's belong together, and our constants belong together. So now we can simplify. So we have 5x squared plus 2x squared, which gives us 7x squared. 3x minus x is going to give us 2x. And 7 minus 4 is going to give us 3. So this would be our answer. For question 4, we have a negative sign being applied to our terms within the brackets. And so we can rewrite our line down below. And now we can apply our negative sign to our terms within the brackets. So a negative and a positive is going to make for negative 3yx squared. And a negative times a negative is going to make a positive. And a negative times a positive is going to make a negative. And now we can collect like terms. So first I'm going to gather our x squared y's. So we have 5x squared y. This is also an x squared y. It's just rearranged. Now I'm going to gather our x's. So we have a plus 3x and a plus 2x. And lastly, I'm going to gather our y. So positive 2y and negative y. So rewriting this, we have 5x squared y minus 3x squared y. So 5 minus 3 is 2x squared y. 3x plus 2x makes for 5x. And 2y minus y is just going to leave us with 1y. So that would be our answer for 4. For question 5, we have 3 polynomials or binomials, but our rules still apply the same. So the sign that's in front gets applied to the terms on the right. So we can rewrite our second line now. So we have negative 3x minus 3. That stays the same because it's essentially positive. Since this is a plus sign, it doesn't affect our signs for our terms within the bracket, so those can also be rewritten with the same signs. However, our negative sign does affect our terms in this bracket, so negative and a positive would make this negative 7x, and negative would make this positive 2. Now we can gather like terms, so first I'm going to start with our x's, so we have negative 3x, positive 2x, and negative 7x. And for our constants, we have negative 3, positive 5, and positive 2. So adding these together, we get negative 7x minus 3, which would give us negative 10x. And negative 10 plus 2 would give us negative 8x. And we have 5 plus 2, which is 7. 7 minus 3 is 4. So positive 4. And so that would be our answer. And for question 6, let's just do the same thing. So in our next line, we have 3jk squared minus 2k. That would become a negative 3k, and that would become a negative j. And everything else would stay the same, 9jk squared minus 4k. So now let's collect like terms. So let's start with our jk squares. So we have 3jk square and a 9jk square. Now for our k's, we have a negative 2k, a negative 3k, and a negative 4k. And then lastly, we just have one lonely negative j. So now we can simplify in our next line. So 3jk square plus 9jk square is going to be 12jk square. Negative 4k minus 3k is going to be negative 7k. And then minus another 2k is going to be negative 9k. So negative 9k. And then we also have a negative j. So that would be our answer for question 6. Once again, I'd like to thank you guys for watching. I hope this video helped you, and I will see you in the next one.